In this problem, we're going to look at an acid-base titration. In an acid-base titration, you generally know either the volume and molarity of the acid, and then the molarity of the base, or you know the volume and molarity of the base, and the molarity of the acid. You could also be given a volume and molarity of one and a volume of another. It's very similar to what we talked about before in the concept of M1V1 equals M2V2, except that was dealing with dilution of a single substance. Now we have two different substances. We have a base, sodium hydroxide, and we have an acid. And the problem is asking us to calculate the volume of the base that's needed to titrate 25 milliliters of a 1.5 molar solution of the acid. The first step right now, since we're going to be relating two different substances, is to write a balanced equation so we can later pull from that the mole ratio. So we know that we are going to have sodium hydroxide. That's going to react with phosphoric acid, yielding, we have our sodium ions and our phosphate ions, sodium phosphate. Remember your charges, +1, -3. And we're also going to have the hydrogen ions and the hydroxide ions, so we're going to have H2O, or HOH, however you want to think of it. Make sure that is balanced. We identify that we have 3 sodium, so we're going to have 3 sodium ions over here. We have 3 hydroxides. Remember, if you think of this as HOH, you have 3 hydroxides, and you also have 3 hydroxides. You would have 3 hydrogens, and again, 3 hydrogens. Everything is now balanced. Now that we have a balanced equation, we can determine how we're going to walk through the problem. We need to, in the end, get a volume out of a molarity. So to get a volume out of molarity, we need to identify the number of moles. So if we can take the moles out of this molarity, we'll be left with a volume. First step, take the volume and molarity of your acid solution, because we have a volume and molarity. So if we take 25.0 milliliters of our phosphoric acid, we can extract the number of moles that are in this amount of phosphoric acid. To do that, we would want to put the volume on the bottom. Remember, now we're dealing with milliliters. So when you're dealing, molarity equals moles per liter. Or you can think of molarity as moles per 1,000 milliliters. Because we're dealing with milliliters, we'll use the 1,000 milliliters. You could also convert 25 milliliters to liters and stuck with the top moles per liter. We know the molarity is 1.500 moles of our phosphoric acid. That will give us a number of moles of phosphoric acid. We can then do the mole ratio to convert from moles of phosphoric acid, which we have 1 mole of phosphoric acid, to moles of our sodium hydroxide. In this case, we have 3 moles of NaOH. Now that we have moles of sodium hydroxide, we can take, if you have moles of a substance, you can set your molarity up so that you have liters or milliliters on top, so the volume on top and the number of moles on the bottom, so your moles cancel. So we can take our molarity for our sodium hydroxide, place the 1.420 moles of NaOH on the bottom, the 1,000 milliliters. I'm choosing to use milliliters because the problem's asking for milliliters. If it wasn't asking for milliliters, you could leave the top as 1 liter as opposed to 1,000 milliliters. And you're going to go through, take your 25, multiply by 1.5, divide by 1,000, multiply by 3, divide by 1, multiply by 1,000, divide by 1.420, and you're going to get the number of milliliters to 4 significant figures, because that's the amount that we had in the beginning. 79.23 milliliters of NaOH.